Extreme cold environments often appear completely lifeless at first glance. With frozen oceans stretching endlessly into the horizon and ice deserts that seem to erase every sign of survival, blizzards can last for weeks, burying landscapes under layers of snow while temperatures drop far below what most known organisms can endure. To the human eye, these regions look empty, silent, and unforgiving, as if nothing could possibly exist in such conditions. Yet this perception is misleading, because beneath the snow and ice lies an entirely different world, one shaped not by absence but by adaptation. Life in these regions does not disappear. It simply becomes harder to see. One of the most iconic survivors of extreme cold is the emperor penguin, a species that thrives in the most hostile regions of Antarctica. These birds endure temperatures dropping below -50 degrees Celsius, along with months of darkness during the polar night. In such conditions, survival depends entirely on cooperation and collective behavior rather than individual strength. Thousands of penguins gather in tightly packed colonies, constantly rotating positions so that no single individual remains exposed to the freezing winds for too long. This shared system of warmth allows them to survive conditions that would otherwise be completely fatal. Their survival is a powerful example of how behavior can become just as important as biology in extreme environments. Beneath the frozen oceans surrounding Antarctica, another remarkable organism exists, known as the Antarctic icefish, a species unlike most others on Earth. What makes this creature so unusual is that it lacks hemoglobin in its blood, the molecule most animals rely on to transport oxygen efficiently. Instead, it has developed alternative biological systems that allow it to survive in oxygen-rich freezing waters. Even more extraordinary is the presence of natural antifreeze proteins within its body, preventing its internal fluids from freezing despite sub-zero temperatures. This adaptation allows the icefish to exist in environments where most vertebrate life would fail instantly. In the same icy oceans, vast swarms of Antarctic krill form the foundation of an entire ecosystem, despite their extremely small size. These tiny organisms exist in massive numbers, creating one of the most important food sources in the Southern Ocean. Whales, seals, penguins, and countless fish species depend on krill for survival, making them essential to the entire food chain. Without them, the balance of the polar ecosystem would collapse entirely. Their presence demonstrates how even the smallest organisms can support some of the largest and most complex biological systems on Earth. In extreme cold environments, survival is often a collective achievement rather than an individual one. Another highly adapted species is the Weddell seal, a marine mammal capable of diving beneath thick layers of ice in search of food. These seals navigate dark, frozen waters with remarkable precision, relying on breathing holes maintained in the ice above them. Their ability to hold breath for extended periods allows them to hunt in areas where access to air is extremely limited. This adaptation makes them one of the most efficient predators in polar regions. Similarly, the Arctic cod thrives in waters near the freezing point of seawater, surviving temperatures that would be lethal to most fish species. It plays a crucial role in the Arctic food chain, serving as a primary food source for larger predators. Even more extreme examples of survival come from microscopic life forms known as extremophile microbes, which exist in conditions once thought completely uninhabitable. These organisms can survive inside frozen soil, deep permafrost, and ice-covered lakes where sunlight is nearly absent. They endure intense pressure, sub-zero temperatures, and prolonged periods without energy sources. Despite these conditions, they continue to function and reproduce at a microscopic level. Their existence challenges earlier assumptions about the limits of life on Earth. It shows that survival is not limited to visible animals, but extends deep into the microbial world as well. At the top of the Arctic food chain stands the polar bear, one of the most powerful predators adapted to life in extreme cold. These animals rely on thick layers of fat, dense insulating fur, and strong swimming abilities to survive in both ice and open water. Their primary prey consists of seals, which they hunt using patience, strength, and environmental awareness. Polar bears are perfectly engineered for survival in freezing conditions, making them one of the most dominant land predators in polar ecosystems. Together with all other cold-adapted species, they demonstrate a shared truth. Extreme cold does not eliminate life. Instead, it transforms it, forcing organisms to evolve extraordinary strategies for survival.